This little speaker here, got another one back there, a couple in ceiling mount speakers, and I need to test these out and see if they work. So you can see this is a two-way speaker. You got the input to the actual cone of the mid-range here, and then you have the output to the tweeter on the opposing side. So if you need to test this real quick, I'm going to show you how you can do it without an amplifier and other external complicated hardware on the cheap too. This is another indisposable part of my test bench, which is just a standard DC 12 volt power supply. Non-variable, so this one here is currently putting out about 12 volts. You can use anything from a 9 volt battery up to something like this, what I'm using, which is just terminated by these two leads, which I'm going to use to test the speaker's phasing. So I'm going to have the cone excursion going forward as well as in reverse, and I'm also going to test the output side on the mid-range as well as the tweeter going after and before the crossover, so I can verify what's going on one side as well as the other. Also, I'm going to be sure to check the impedance. So if this woofer is 8 ohms, this one here can tell me with a multimeter if it has a dead short, or if the impedance is going to tell me a story where you might have a deficiency in the cone. You could also push the speaker in and out and watch the impedance on this tool as well to see if you have a break in the coil inside there, which you can't tell by physically seeing the speaker moving when you pop it in and out with the DC voltage, which I'm going to use by that power supply or any other way. So a couple things you're going to learn here today. So the first thing we're going to do is this speaker should be rated at 8 ohms since it's a home product. Most home products are. In some cases they're 4 or 2, but you know, the lower the impedance, the higher the output's going to be, or the stress on the amplifier requirement is going to be. So make sure you're using impedance matched products. So all you're going to do is just take your meter. I know it's going to be approximately 8 ohms, so the lowest setting on here is 200. I'm just going to stick this right in the terminal. Get my reading on here. 7.6. Perfection. Now, another thing you could do, depending on how good your meter is, you can actually push the woofer, and as you're doing it, you'll see the numbers on the meter impedance switch, which will tell you if you have a break in the coil, which is inside the spider in between the magnet and the actual cone structure itself. But you don't have to be that fancy. This is a quick video, right? Now, to verify if this speaker works, all you need to do is take power from your battery, whether you're using a 9 volt battery really cheap, or if you're using a power supply like I am. Over here you're going to have your input, right? Your tweeter side right here, and this here is your output from the output of the capacitor windings for the mid-range to the woofer. So when you apply voltage, negative to negative, positive to positive, respectively, this is what's going to happen. Watch the cone. When the cone travels outward, that's when it's in phase. You can also go backwards, and it'll tell you how the coil reacts that way. Now it'll just simply suck in. Now, as far as your tweeter goes, you might want to be careful on tweeters, especially when you're using a high voltage like I am, 12 volts, to a tweeter. Now this is a really great speaker, but on some speakers you got to be careful. You might want to utilize like a 9 volt battery or something a little lower, because all you want to do is just basically hear if that tweeter's crackling. I'm sure you can clearly hear that. You can't do a polarity test really on a tweeter for the most part, because there's very little, if any, moving structure on this one. This one here is just a silk dome type of tweeter. There's really no moving components that you're ever going to be able to see with your naked eye, so forget that. You could also do a continuity check with your meter if you wanted to do a quick check on your coils to see if they were burnt up and not making connection through the coil and they had a break. In this case I'm going to go underneath because it's really challenging to find it on the other side. That's the sound you're looking for. When you get a buzz from a meter such as mine that has the audio goes beep, that lets you know that you have a circuit. A good continuity check will do that. That's all that's required really to test the speaker. So for basic checking, you know, without using an amplifier or some other external source, real quick, that's how I do it. So you can get a good idea of your impedance, what you're working with, if it's working, how the cone structure is, check your crossovers, check your inputs, outputs. What else can I say? That's how it's done.